Dear students, in this session let us discuss about the greatest common divisor. In short we write as GCD or highest common factor HCF. Let us consider the two integers, say 12 and 15. We know that the divisors of 12 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6 and plus or minus 12. Again the divisors of 15 are plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. Observe from these two these divisors, the common divisors are plus or minus 1 and plus or minus 3. From these common divisors, the highest positive divisor is 3. The highest positive divisor is 3. Therefore, here the positive greatest common divisor is 3. So, this is the GCD. This is the GCD. GCD of two numbers is written like this. So, the GCD of 12 and 5 is 3. Let me see the formal definition of the GCD. The GCD of two non-zero integers is the largest or greatest positive number that divides both the numbers without leaving any remainder. For example, 3 divides, because 3 is the GCD, 3 divides 12, 3 divides 15 without leaving any remainder. So therefore 3 is the GCD. Another definition for GCD is any positive integer, say D, is said to be the GCD of A and B if D divides A and D divides B. As I said in the here, the GCD of two numbers is written in symbol like this. Okay. Actually, this method, okay, by this method is not advisable when the two numbers are in big quantity. Therefore, we can find out the GCD by this method, by division method. Let us find the GCD of these two numbers, 12 and 15. Take the smallest number as a divisor and another one as dividend. We have to divide this process until to reach the remainder is 0. Let us start the division. 12 ones are 12, remainder is 3. Again take this remainder as a divisor and this divisor as a dividend. 3 4s are 12, so we arrive at the remainder is 0. The GCD is the last non-zero remainder. Here the last non-zero remainder is 3. Therefore, this is the GCD. Therefore, last non-zero remainder is the GCD. Therefore, the GCD of 12 and 15 is 3. 12 and 15 is 3. Okay, let us take one the note. If the GCD of A comma B is say D, then D, this GCD D can be expressed as a linear combination of A and B. That is, the GCD D is expressed as in the form of AX plus BY. So here X and Y are integers, we have to estimate. Okay, this is called linear combination. Let us take one problem. Let us find the GCD of the two integers 150 and 210 and express it in the linear combination of these two integers. As I said, take that is let A is equal to 150 and B is equal to 210. Take the smallest number as a divisor, another one is dividend. Let us start the division. 150 is 1 times, you will get 150. Subtraction, after subtraction you will get 60. Observe here, as this is the dividend, that is A, is the divisor is 150A and dividend is B, say, and this is the quotient and it's a remainder. Now actually we know that in a division process that B is equal to AQ plus R. So here A and B are two integers, Q is a quotient, R is a remainder. B is equal to AQ plus R. R, for convenience, I write R is equal to B minus AQ. Please keep it in mind that R is equal to B minus AQ. Now R is 60. Observe here, R is 60 is equal to B, the value of B is how much? 210 minus AQ. A is 150, Q is 1. Okay. In each step, write this form. Okay. This process is known as Euclid's algorithm. Euclid's algorithm. As I said, that is until to reach the remainder is 0, we have to take the division process. Next, take 60 as a divisor and 150 as a dividend. Let us say 60 2 times you will get 120. Subtraction you will get 30. Again, using this formula R is equal to B minus AQ, the R is 30 is equal to B is 150 minus AQ. A is 60 into Q is 2. Okay. Again, take the division 30 2 times 60, so you will get 0 is a remainder. The GCD is the last non-zero remainder. Last means previous one. Last non-zero remainder is how much? 30. Therefore, this is the GCD. Therefore, the GCD of the given two integers 150 and 210 is 30. Now, we have to express this GCD as a linear combination. Now, consider the equation 2, that is GCD is 30 is equal to 150 minus 60 into 2 times. Now, by back substitution, thus 30 is equal to 150 minus this 60 can be replaced as how much? 210 minus 150 into 1 times, that is equation 1. Therefore, by back substitution, that is equation 1. Use equation 1. Okay, that is back. So 30 is equal to 150 minus 60 is replaced how much? 210 minus 150 into 1. 210 minus 150 into 1 into 2. Simplify this. So we get 30 is equal to 150 here 1 times, here 2 times. That is 2 plus 1 3 times. Plus 210 negative sign minus 2. This is of the form D is equal to, here D is the GCD, D is equal to A is 150 AX plus BY. So this is the linear combination of the given GCD, of the GCD. 30 is equal to 150 into 3 times plus 210 into minus 2 times. Here A is 150, B is 210, X is 3, Y is minus 2. Okay, this, as I said, this process is known as Euclid's algorithm. Let us take the second problem. Find the GCD of 408 and 1032 and express it in linear combination. There is an extension of there is a problem is also show that this linear combination is not unique. Okay, linear combination is not unique. First, let us express as a linear combination. Here A is 408 and B is 1032. Take 408 as a divisor and 1032 as a dividend, and take the division process. 408 2 times 816, remainder is 216. As I said, that R is equal to, here R is equal to B minus AQ. A is 408 into Q. Again 216, 408 1 times, you will get 216, remainder is 192. Express as R is equal to B minus AQ. Again take 192 1 times, remainder is 24. Again 24 is equal to B minus AQ. Again 24 8 times, you will get 192, remainder is 0. Now stop the division. The previous non-zero remainder is the GCD. Therefore, the GCD of 498 and 1032 is 24. Now the equation 3, that GCD 24 is equal to 260 minus 192 into 1. By back substitution, therefore for 192 use equation 2. because 192 is expressed as 408 minus 216. Okay, I have replaced here. Again simplify here. 216 minus 408 into 1 times, minus into minus plus 216. Observe here, 216 2 times plus 408 minus 1 time. Again observe this, we use the equation number 2 only. Again equation 1 is there. Equation 1 is 216 is expressed like this. Now replace for 216 equation 1. Equation 1 is 1032 minus 408 2 times. This is 1032 minus 408 2 times into 2 plus 408 minus 110. Again simplify, so we get 1032 2 times, 408 minus 4 minus 1 minus 5 times. This is of the form D is equal to AX plus BY. AX plus BY. Here X is minus 5 and Y is 2 here. This is the linear combination. Now we have to show that this linear combination is not unique. Next, to show that the linear combination is not unique is a very important step. We have to add and subtract 408 into 1032 in the RHS side of this above equation. Okay, 408 into 1032. This 408 into 1032 is a given two integers, A and B. Okay, in the above equation we have to add and subtract in the right side. Okay, the 24, the above equation is, the 24 is equal to 408 minus 5 plus 1032 into 2 times. Observe here, I have added 408 into 1032 added. Again minus 408 into 1032 is subtracted. So without loss of generality we can add and subtract. After add and subtract to the above equation, observe here, this is 408 minus 5 is a negative quantity. One more negative quantity is minus 408 into 1032. Now add them, these two negative quantities and positive quantities. 408, take out common outside, minus 5. Here if you take 408 as common outside, minus 1032 plus 1032 common outside, left out is 2 plus 408. Simplify, 408 minus 1037 plus 1032, this is 410. This is of the form D is equal to AX plus BY. Observe here, X and Y are different. For the previous linear combination. As I said in the equation star, X is minus 5, Y is 2. But here X is minus 1037 and Y is 410. So X and Y are different. Therefore the linear combination is not unique. Thank you.